Hello, welcome to our third module on the cloud, the method of cloud adoption. So let's start the lecture now. In this lecture, I will explain cloud security and the authentication techniques, how to calculate the cost of cloud adoption, the process of transfer to the cloud, and the post-adoption management plan. This course is intended to help you understand security schemes and how to calculate cloud adoption cost. Also, through this lecture, you will be able to understand more about the process of migrating a system to the cloud and managing it after adopting the cloud. To achieve the above objectives, this lecture includes the cloud security threat and the security technology, cloud adoption cost, and the service level agreement, which is a contract for cloud service quality level, cloud migration process, and the post-cloud management plan. Cloud security threats can be divided into threats that existed before the cloud and the new threats posed by the cloud. First, there is the threat of virtualization. Virtualized machines are easier to break into than physical machines. Using this weakness, a hacker can use his virtual machine as a route to break into others' virtual machines. The cloud shares resources between tenants by a multi-tenancy technique. However, a user can access other people's resources if even a small error exists in the environment setting. Since the cloud is also accessed through the public network, there is always a high chance that it can be dropped through the network, or a malicious intruder can break in. Hackers can distort or wrap cloud services and steal the information they need through web service language scanning. Hackers can steal cloud administrator rights and tamper with or leak data through forgery of access rights, manipulation of identifiers, and anonymization. Hackers also attempt attack that place a huge burden on the cloud through DDoS attack or rapid creation of virtual machines. There are also security weaknesses due to errors in the cloud design or implementation process. Cloud security threats can also be divided into technical and non-technical threats. As explained earlier, technical threats can be divided into security threats that existed in the legacy computing system and the threats posed by cloud virtualization. Non-technical threats consist of administrative issues and the issues related to regulations. Management-side issues include design management errors by insiders, leakage of users' account information, provision of excuse for hacking to a variety of hackers, physical damage to the data center from disasters such as fire and earthquake, and the resulting data loss. Legal issues include resource control issues, and for geographically dispersed infrastructure, policy gaps caused by disparate legal systems across multiple countries. The cloud is more likely to experience security issues due to virtualization. This refers to a security problem that can occur due to a virtualization environment in which virtualization makes it more difficult to defense against existing security problems or increases the ripple effect. For example, there is something called a virtual machine attack vector, as users' virtual machines are interconnected. There are many attack paths such as packet sniffing, hacking, DDoS attack, and malicious code propagation from a virtual machine to another virtual machine. In addition, hackers also target the hypervisor itself, which is the basis of the virtual machine. In the cloud, we have the problem of attacker anonymity. In a virtual environment, it is difficult to identify the attackers. As such, it is difficult to detect an intrusion into the virtualized internal area using the existing network security technology. For example, when a security problem occurs during web hosting through the cloud, it is difficult to know who performed the attack because it is difficult to identify which services are running and how to access them. There is also a problem due to the mobility of the virtual machine. In a virtualization environment, it is easy to move virtual machines between physical platforms, and this may cause a problem of the spread of infection. That is, virtual machine infected with malicious code or a virtual machine without a security patch can easily spread to other physical platforms, causing a problem that can quickly impact cloud hardware. We may experience security issues when sending user data to a cloud server over the internet. These issues can be solved using a mix of TLS, SSH, and VPN. In case of SaaS or PaaS, cloud services often use HTTP as a communication protocol. In case of IaaS, security can be strengthened using VPN provided at the switch or router level, and as well as SSH. Cloud storage is a system in which user data is stored. It utilizes encryption for stored data. The data stored for each cloud service is different, and the encryption and containment measures are taken in consideration of the sensitivity of the data, where it is shared or not, and whether it is subject to regulation. To prevent data loss, external traffic is monitored and blocked at the network level. FIDM is used to allow users to access cloud by authenticating their user ID. FIDM is a concept similar to entering a mobile phone verification number. It allows for effective response to security incidents by transmitting log data to a separate SIEM. Analysis of system log data is the most basic way to respond to security incidents, and the system log data includes user login and virtual machine creation, movement, destruction, generated data traffic, used applications, database access, operating system, and the system operation, record information, etc. Maintaining independence between virtual machines is a very important technology for cloud security. The system can be protected by maximizing the virtual network security benefits of a virtual machine against the threats to shared storage and shared networks. It provides complete isolation between virtual machines accessed by users, preventing sniffing on data and the traffic of other virtual machines in the cloud environment. The hypervisor limits the scope of access rights to the virtual machines. Physical resources stores the data in an encrypted form and prevents access to data that remains somewhere in the storage even if it is deleted later. Intrusion can be detected by analyzing virtual machine internal information using a hypervisor. This technique analyzes the internal state of each virtual machine and detects intrusion through the hypervisor. That is, malicious behavior is detected through analysis of internal information such as virtual CPU registers of the virtual machine, content of the virtual memory, file input-output activity, and the network packet capture generated by each virtual machine. It also provides services such as IPS function, firewall, and antivirus on the hypervisor. Intruders can be deployed using the inside information of the virtual machine in various ways. The first method is to analyze the internal state of each virtual machine and detect an intrusion through the hypervisor. Malicious behavior can be detected through the analysis of internal information, such as virtual CPU registers of the virtual machine, content of the virtual memory, file input and output activities, and the network packet capture generated by each virtual machine. It provides services such as IPS function, firewall, and antivirus on the hypervisor. The second method is virtual machine detection, also called agent-risk virtual security detection. In this method, the intrusion detector operates on a security-only virtual machine with separate special privileges rather than as an agent within each virtual machine. Efforts to comply with security standards through cloud security certification systems are spreading across countries. International public standards organizations centered on ITUT and the ISO IEC JT31 provide cloud security certification services. Obtaining security certification means that the minimum information protection requirements for using the cloud service have been met, and damage can be minimized even if a security accident occurs. As shown in the table, information security and the security controls and the security standards that can be used by governments and the industries have been established and are widely used. In the event of cloud security accident, it can be addressed by a compensation system or insurance. Through the cloud SLA, SLA means service level agreement, users can sign contracts for service level management, such as data protection, account management, and application operation. SLA is an agreement for cloud service providers to guarantee the quality of services by quantifying the level of service to users and clarifying notifying them, and compensating for damages if the level of service is not met. In the case of global companies, in case of security damage, 10 to 50% of the usage fee is compensated according to usage. And in the case of Korea companies, 3 to 15% and 3 times the amount charged during the time of failure are compensated. For example, Amazon AWS pays about 10% of the monthly fee in compensation. When a cloud user experiences unexpected damage due to a system error, natural disasters, etc. While using the cloud, a compensation service is provided through cloud insurance. In case of emergency such as fire outage, etc., in geographically dispersed cloud data centers, safety systems for quick response and through security management such as access control and intrusion prevention in the data center are required to ensure stability. To calculate the infrastructure service cloud cost, cloud service providers provide their own total cost calculator. Using this total cost ownership calculator, users can calculate the infrastructure service cost for each component and compare the cost. For example, Microsoft Azure Cloud calculates cost based on computing and networking, disk storage, and IT personnel. Amazon AWS calculates the cloud usage fee based on server, network, hardware, bandwidth, management cost, storage cost, etc. For example, let's say that two cloud companies' usage fees were quoted and compared, and the results were as listed in the table. In this case, when it comes to hardware and infrastructure with the same specifications, it would be advantageous to choose a cheaper cloud. Since software service called SaaS cloud cost consists of the cost of software providing the service, the cost of infrastructure to run the software, and the cost of operation, you need to compare the cost of purchasing the software and running it on your own server with the cost of SaaS. The cost of the platform service cloud is determined by the number of developers, the number of API calls provided, the number of database calls, etc., according to the functions provided by each cloud service provider. In order to select a cloud service provider, you need to compare the cost of introduction and check whether the service adequacy and the quality of the cloud service provider meet the service level required by the company. The purpose of defining the service quality level is to define the service quality level through a contract between the cloud adopting company and the cloud service provider, and to use it to select a company capable of providing the service quality level desired by the adopting company. In addition, if there is a difference between the service provision level of the cloud service provider and the level requested by the enterprise, definitions are used as adjustment data. In order to set and compare the level of cloud services, the following needs to be considered. First, clarify the purpose of writing the service level agreement. The service level agreement should clearly describe the service area, details, characteristics, etc., provided between the enterprise and the cloud service provider. Second, the service level metrics should be clarified. The selected service level metrics should be clearly measurable through automated tools or monitoring systems to prevent dispute in advance. Third, target service levels should be set. The target levels are managed by setting the maximum target level and the minimum target level. Fourth, service level evaluation and management should be conducted. It should be specified in the standard contract so that the first penalty and the damages can be settled based on the incentives and penalty clauses set in advance for the service level evaluation result. Service availability items include availability, mean time to recovery, and the mean time between failures. Items related to service failure include items such as average time taken for maintenance, average failure time, failure cause identification rate, number of excesses over the maximum allowable failover time, and the total number of failures. Items for measuring cloud service performance include mean response time, the number of excesses over the maximum response time, the maximum number of concurrent connections output rate, and the electricity rate. The migration of applications to the infrastructure service cloud process in the following order: preliminary review, environment configuration, application installation and configuration, security enhancement, system testing, and operation. In the preliminary review, the structure of the existing system in which the application was running is checked. After that, the cloud team set up the cloud environment. Setup tasks include computing virtual networks, creating virtual machines, allocating virtual storage, and setting up firewalls and VPNs. Then the cloud team installs applications, installs security-related systems, and set up user accounts. Next, it includes steps such as service level, security level, data transfer, and the system pilot operation. Finally, it starts operation after checking the failure response plan and the monitoring system. The transfer of the system to the SaaS service is similar to the new introduction of software provided by the cloud service, and the transfer is carried out by considering the following methods. First, the data conversion process is required when transferring existing data. Second, when transferring existing data to a new SaaS, the existing data should be convertible to the data format used in the cloud. Third, when performing work in SaaS with new data, it should be possible to maintain the existing system for a certain period of time. In other words, it is necessary to share data between the existing system and the new cloud service and to adjust business processes. SaaS is adopted through the following procedures. First, user authentication is required to use SaaS, and the cloud team must check whether it is compatible with the authentication scheme of existing system. Second, the cloud team redesigns the business process in line with how SaaS tasks are handled. Third, the cloud team redesigns operational processes such as monitoring, backup, and security. Fourth, the cloud team trains users to use SaaS. The cloud teams should consider the following when migrating to PaaS. First, the cloud team must redesign the business logic. Redesign of business logic is unavoidable because business development is dependent on PaaS. Second, the development environment must be reconfigured. The development environment must be reconfigured with the development tools provided by PaaS. Third, security should be strengthened. The cloud team should strengthen the security team through system reconfiguration using backup, redundancy, monitoring, and the security solutions provided by PaaS. Fourth, the cloud team should strive to maintain business processes and the IT operation process After the system development is completed, the cloud team should be configured to be similar to the previous business process and the IT operation process. After cloud adoption, the cloud team regularly evaluates whether the preset service level and the security level are being met to improve the service. For service quality level management, regular service level evaluation is required, and the service level goals need to be increased. In order to manage the security level, regular security level evaluation should be performed, and the security goals should be achieved on a continued basis. After the introduction of cloud, the cloud team conducts enterprise-wide change management training. First, education on the use of cloud service is conducted. Cloud usage training includes company-wide training on how to apply and use resources in the cloud environment, company-wide training on changed IT process, and prior training for company-wide scaling, such as training on the necessity and the effectiveness of cloud adoption. In addition, the cloud team conducts IT organization training. This includes cloud adoption guides training and the training on systems changed by cloud adoption. For post-cloud management, the cloud team must check whether the cloud computing adoption goals are being met. After cloud introduction and operation for a certain period of time, the cloud team needs to check whether the introduced cloud service meets user requirements through a questionnaire. For systems that have been reviewed or put on hold in the introduction of cloud computing, the cloud team needs to review the availability of cloud computing and expand the scope of cloud computing. In this lecture, we looked into cloud security threats and how to deal with them. Security threats caused by cloud virtualization and resource sharing are challenges that must be overcome. In addition, we looked into the process of calculating the cost of adopting the cloud and the items comprising the cost. We also looked into SLAs and the key service quality items that users make with cloud service providers to use the cloud. In addition, we looked into the process of migrating to the cloud and the items to be managed after moving to the cloud. I consulted a number of references to create the lecture material. Thank you for your attention. If you have any questions, please feel free to contact me by email yklee2000@gmail.com, and I will answer you directly. Thank you very much again.